Alrighty, this video is going to be fun. Basically, what we need to do is we need to dynamically create a method that will invoke another method. So if you guys aren't familiar with reflection, there's a way that I will be able to invoke, let's say method, this method right here in iTest component 2. There's a way for me to be able to invoke that dynamically without having a hard-coded reference to that method in my source code. It's actually pretty straightforward. Basically what I would do, I'm just showing you guys some basic code right here. I would do something like method info equals type of iTest component 2 get method. Then I would say method info dot invoke. I would first pass in an object that's of an appropriate type. For example, an object that is an instantiation of a class that inherits from iTest component 2. And then I can also pass in a array of objects as parameters. Now that's really cool and all, but the problem is that the invoke method on method info is very, very slow, and that's problematic. So what I want to do is I want to dynamically create a straight up bit of IL, an actual dynamically created method that'll be injected into our app domain that'll allow us to invoke these methods without having to go through the method info.invoke method. So this will give us an excuse to take a look at some really cool features that were fortunately introduced in .NET 3.5 that will allow us to make that optimization. So, okay, so let's talk about tests first. How do I want this to work? So let's go ahead and I'm going to write up a test of how I want this behavior to work, and it'll also give you guys a good understanding of where I'm going with this and what I'm trying to accomplish here. In order to write this test, though, I will need a actual component, an actual interface, as well as a concrete type that I can measure. As in, I can be able to say, okay, was this method actually called on this concrete type? Because we need a way to test this, obviously. This is a very important aspect of the system. So what I'm going to do is I'm going to introduce a new test component, iTest component 3. And the reason I'm doing this is because the iTest component and iTest component 2 are already being depended on in a variety of tests, and since these type of tests that I'm about to write are so different than those other type of tests, I don't want to confuse the interfaces. So let's go ahead and write a couple methods. I want to say void, let's say void method no params, and then let's do void method 1 param, string param1, and then void method 2 params, and then let's do bool param1 int param2. Then I'm going to write a class called test component 3, which will implement iTest component 3, and it'll have those 3 methods. So I'm just going to go ahead and oh, come on, there you go. I'm just going to have RSharper generate those method stubs for me. So I have void method no params, void method 1 param, void method 2 params. So then I'm going to go ahead and I'm going to write 3 properties. So int void method no params call count, get private set. Then I'm going to say public int void method 1 param call count. I'm doing this so I can actually measure if these methods are getting invoked when I think they should be. And then I'm going to say public int void method 2 params call count, get private set. Then I'm going to create 3 more properties. Public string void method 1 param param1, and then public bool void method 2 params param1, and then finally public int void method 2 params param2. So basically, the implementation of this class is going to be pretty self-explanatory. Every time void method no params is called, we increment its call count. Every time void method 1 param is called, we increment its call count. And then I'm also going to say void method 1 param param1 equals param1. so that we can ensure that arguments are properly being funneled into the methods. And then I'm going to do void method 2params call count plus plus, void method 2params param1 equals param1, and then we'll do the same thing for param2. Okay, really straightforward class. Basically, all it does is it records which methods on it were invoked, which will work for our purposes. Now, there's another interesting thing that I want to do with this particular test, and that is because we are going to be mapping this repeatedly, and it's basically going to be the same map every time, and since we've already established that our component map works, and that we have tests to ensure that it still works, I'm going to write a method that isn't going to be a test. It's going to be on our fixture, but it's not going to be a test. And what it's going to do is it's going to return an instantiation of a component map where our test component 3 is all mapped, so we don't have to repeat that over and over again throughout our tests. So I'm going to do this at the bottom of the file. I'm going to split my screen here so I can look at my signatures of my methods while I scroll all the way to the bottom of the file. Because I kind of like in my test fixtures for my tests to be, the first methods in the class, and then my helper methods I like to put either in a partial class or at the bottom. So what I'm going to do is I'm going to say private component map, and then I'm going to call this create test component 3 component map. And the component map is, I'm going to say component map equals new component map. I'm going to say var component equals component map dot map component type of itest component 3, and let's give it a component ID of 0, just so that's easy to remember. Then I'm going to say component dot map method. I'm going to say type of itest component 3 dot get method void method, and I'm going to give this an ID of 0. And then I'm basically going to do this 3 more times. And I'm going to do it for void method 1param and void method 2params. And I'm going to make sure that the first one is 0, the second one is 1, the final one is 2. The last thing I want to do with this method is return the component map. So this way I can just quickly go ahead and map the component for however many tests that I want to make for my my testing of component 3. Some people would consider this to be a different test fixture and may want to do that as well, but in this case I'm going to lump it all into this single test class. Alright, I'm going to get rid of the horizontal split here, and I think I'm just going to work from the bottom here, just because it makes more logical sense to me. So let's go ahead and write a test. What's the test going to do? Well, the test will first need to instantiate a component map and map the components. That's all fine. That's already tested. The second thing that it's going to need to do is it's going to need to invoke one of these methods on an object that is an instantiation of our test component 3 class. And the final thing it's going to need to do is to ensure that those methods were invoked, or at least that method was invoked. I'm probably going to just be testing one method per test in this particular scenario. So this test will lead us to a lot of interesting decisions, like, for example, how do we want to structure the way that we access methods, and how do we want to invoke them? Well, I already have an idea for that in mind, so let's go ahead and write some code. And again, this code won't compile yet, and that'll be fine though. So I'm going to say public void, I'll say can invoke void method on component. I'm going to say var map equals create test component 3 map, and then what I want to do is I will say map dot methods at 0 at 0, and then I'm going to want to say invoke, and I'm going to want to pass in something. Now what do we need to pass in here? Well, we'll need to pass in A, our parameters, or arguments in this case, and B, a instance of the class we want to invoke that method on. Now in this case we won't have any parameters, so what I'm going to do is first I'm going to, actually I'm going to do this before, I'm going to do this after my, I instantiate my map. I'm going to say var component object equals new test component 3. Then I want to say methods 00 invoke component object, and since there won't be any parameters for this method, I'm just going to not supply a second parameter. Then I'll have an overload when we actually create the invoke method that'll accept. Actually, nah. you know what I'm going to do? I'm just going to say component object, and then I'm going to pass in null as a second parameter, as a second argument, I mean. And we'll see how this makes sense later. But basically, like I said, yeah, we would need the arguments, but in this case it has no arguments. Do I want to make an overload? I kind of don't want to make an overload, so we'll just go with this. Then I want to say component object dot void method no params call count should be 1. So that's our test. Basically, we're making sure that given two numbers, two identifiers, we can invoke a method on an interface against a concrete object. So I hope this whole component map concept is starting to make sense here. Because if we receive, for example, an instruction from the server to invoke a particular method on a particular object, we would just need 2 of these byte-long IDs, so a total of 16 bits, in order to select a method to invoke on an object, and then we invoke the invoke method, which handles this in an efficient way, and then we pass in the concrete object that we have instantiated and lying around. So that's how we're going to handle this, and it's a very efficient way of doing this, but it will require some work once we actually get into dynamically creating code. Anyway, to make this test even compile, we do need the invoke method on our mapped methods. And the invoked method, and I'm finger quoting right here, but I guess you guys can't see that, so instead I verbally stress the word, won't actually be a method. It'll be a delegate. And the reason we're doing that is because we will be receiving a delegate from the process of dynamically creating code. So we'll be able to just plug that delegate straight into a delegate property on our mapped method object. So what I'm going to do is I'm going to jump into our Buzz MMO base infrastructure, and I'm going to go into the mapped method class. And on the mapped method class, I'm going to create a public. Now I'm going to do something interesting here that you guys might not see coming. I'm basically cheating in the whole TDD thing because there is one thing I know I'm going to need later down the road that I'm not testing for yet, but I still want to have it in here so that I don't have to jump back into this class and tear it up again once I get this done. So what I want to do is I want to say public public func of object array, which returns an IRPC response. And then I'm going to call it invoke. And bringing in func will require me to bring in system. And I'm going to make this a property, get private set. Okay, so this is going to be the delegate that is going to refer to the dynamically created method that we're going to write. And as you see, it takes in an object array, and returns an IRPC response. So the first parameter is going to be the object we want to invoke the method on. Second parameter is going to be the arguments that we need to pass in to the method invocation. And then the return is going to be an IRPC response, and for void methods that'll be null. So what is an IRPC response? Well, that's an interface that I came up with that will allow us to basically have for certain operations such as logging in or moving an item in inventory or making an auction house transaction, you really want to be able to write code in such a way that will say, do this thing, server, and then when you're done, tell me what you did. And I implement that concept through the IRPC response interface. Now we don't have that written yet, and I'm about to go ahead and do that. So I'm going to, in my infrastructure namespace, I'm going to create a new class, new interface. I'm going to call it IRPC response. And for now, I'm just going to leave this blank. The only reason I'm even talking about IRPC responses here is because I want to get this interface just there so that I can write code against it, even though we're not going to be using it yet. We'll fill this in later. But for now, just know that it is the object type that is going to be returned by invoking one of these methods. Alright, so now our code will compile, but unfortunately our test will fail. It'll be a null reference exception because obviously we're not assigning anything to our invoke property. So what I'm going to do is basically I'm just going to say invoke equals, and then I'm going to say compile method invoker, and I'm going to pass in the component dot type as well as the method info. Then on this class, I'm going to write a private static func of object, object array, and IRPC response, compile method invoker, passing in a type, let's just say type, and then a method info method. So this static method right here will be the thing that actually performs the compilation of the stuff. So, well, what do we have to do here? So we have to go ahead and create an expression tree and then compile it. So what is an expression tree? Well, it's interesting because it's a feature that you probably already used in .NET, but may have not realized it. Basically, an expression tree is a way to pass code as data. It's a very interesting concept. Effectively, if you're familiar with what an AST is, an abstract syntax tree is, it's like that. If you're not familiar with what an AST is, it's a way to describe code in data. So for example, let's imagine that we were describing this method as data. What would we have? Well, we might have a instantiation of a method object, and then that method object might have a return type of this, and then it might have two parameters, and these two parameters are typed, for example. And then maybe this method has an if statement, and then maybe has a method invocation. So imagine this method being turned into data. As opposed to being compilable code that actually executes things on our computer, imagine it being in an array of objects that just describes what the method does. Well, that's what the expressions in .NET, that's what they allow us to do. And they also give us the really awesome feature of being able to take one of those expressions and turn it in to actually dynamically compiled and injected code. So I'm going to talk about each one of these little bits as I write them, but if you, just let me know if you guys want a more in-depth detail or a more in-depth explanation of the System.Linq expressions. They're very powerful, and they were very much expanded in .NET 4, which is unfortunate because our base project has to run against .NET 3.5 because of Unity. So unfortunately, there's some nasty things that we're going to have to do until Unity gets its act together and updates its runtime. Okay, so another interesting thing about how to build an expression with this whole thing is that all these objects are immutable, so we have to instantiate them in a very particular order. Pretty much we have to instantiate them inside out. All right, so we're compiling a method. We need to first describe the method. As in like what parameters it takes and all that fun stuff. And before we do that, actually, let's go ahead and I just want to show you guys in actual C# code what I want this method to look like. I want the method that gets compiled. So this is an example method that will get compiled of object, obj, object, params, or how about args. And then I want it to look like this. I want to say something like test component obj dot method or int args0 bool args1, something like that. So this is the method that I want to actually go ahead and compile dynamically, but I'm going to need to put in my own example or my own type for test component and my own method for method, because I need to do this on every single method that our component map is mapping. So to start off, what's the first thing I need to define a method other than its return type or its name? The answer to that question are its parameters. So what I'm going to do is I'm going to create a couple parameters. I'm going to say var target object parameter equals expression. Now expression will bring in System.Linq.Expressions. Expression dot parameter type of object, and I'm going to call it target object. Then I'm going to say argument array parameter equals expression dot parameter type of object array, argument array. Okay, so what I've done so far is I've basically created these two parameters. Now they're not hooked up to anything yet. They won't do anything until I plug these little objects into different bits of the compilation process, but we'll just have them hanging out there so that we can use them when we need to. Now, I need to do basically two more things. I need to actually, I first need to create this bit, because remember, we need to work inside out. So we've already done this bit. We've created our two parameters. Now we need to create the thing that actually converts the individual items in the args array into the types that they need to be. So to do that, I'm going to need to create an array of expressions. And I'm going to do that by using some LINQ here, and I'm going to have a helper method. So I'm going to say var arguments equals method dot get parameters dot select. Then I'm going to pass in mi for how about pi, parameter and index, and then I'm going to say convert method info parameter, passing in the parameter, the index, and then the argument array parameter. Now, of course, select won't work because I don't have System.Linq imported. So I just do that up here. I get a System.Linq at the top. Now I actually have to write the method that's going to perform the conversion. And that method is going to be a private static expression convert method info parameter, taking in a parameter info, an index, and a expression argument array parameter. Okay, so now you guys can see what step we're on basically. So I need to, what we're doing here is we're getting all of the parameters that this method supports, and then we're transforming them into these expression arguments. These expression objects. And we do that by using this method that we're going to write. This method takes in a parameter info which describes the parameter of the method we want to invoke. So imagine this method right here. This guy has two parameters, a param1 and param2, one of type int or bool and one of type int. And so that's what the parameter info describes. So we get one of these invocations for every parameter that the method we want to invoke has. Next up, we get the index. We need to know the index of the parameters so that we can index the correct item of the argument array parameter, which we have right here. So this is actually only going to be one line. I could have done this in line in this lambda right here, but I chose to break it out into a different method for clarity. So what I'm going to do here is I'm going to say return expression.convert expression.array index argument array parameter expression.constant index parameter info parameter type. All right, so what's going on here? Basically, each one of these lines that executes gets turned into this bit right here. And you can actually kind of see that. On the outside, we have an expression.convert, which is this cast right here. So we convert this bit, which this bit is this bit right here, into parameter info.parameter type. So in fact, I can go ahead and, when I'm working with expressions, I commonly have a very specific sort of indentation style that I like to use, because it makes it a little bit more clear what's going on as long as I can get my parentheses matched up. There we go. Okay, so the first thing is we do an expression.convert, which is the cast of the type that we need to have it be. And the next thing we do is we do an array index. So we need to do an array indexing operation. That requires we pass in the actual argument array parameter that's going to be passed in. For example, args right here. And then we need to pass in what do we want to index it to. Well, we're simply going to do expression.constant index, which expression.constant allows us to pass in a constant value into our method that we're compiling. Okay, now that I have that done, so I have this list of parameters, I now need to do this bit, the bit that actually converts the object that we passed in into the right component type, and then second, invokes the method that we want to invoke on it. So what I'm going to do here is I'm going to say, well, of course, I'm going to want to go inside out, so I want to say var call expression equals expression dot call. Now, what are we calling? Well, we need to first pass in the instance. So what is that going to be? That's going to be expression.convert target object parameter to type. Now, what's the method that we're invoking? Well, we're invoking method. And what are the arguments we're passing in? Well, we're passing in arguments. So we're passing in that thing that we just constructed. So if I break this out so it's a little bit more clear as far as what's going on, we'll see that we first do the conversion, and then we invoke a method on it. Just like what we're doing here. So this bit directly correlates to this whole piece. But we're not done yet. We actually have an interesting consideration to think about because of the way that .NET 3.5 handles expressions. Now, unfortunately, this problem wouldn't happen in .NET 4, but since we're constrained to 3.5, we're going to have to deal with it. So what we need to do is we need to always have these method invokers returning an IRPC response. That just needs to be a given, because otherwise we would have to write a lot of other conditional code later down the line for every time that we invoke one of these method invokers. But unfortunately, our RPC framework supports methods that return void. So what happens when we try to have an expression that all the expression does is invoke this stuff, but if this stuff returns void, how do we return an IRPC response? We can't do it. Now, you might be thinking, well, I mean, clearly this works right here. Well, imagine it looks like this instead. Now, what do we do? Well, you would say we could just compile it like this. And it would be super straightforward and super easy, and that would be awesome. Well, you can do that in .NET 4, you can't in .NET 3.5. Reason for that is that in .NET 3.5, there's no such thing as a block. Meaning, every single expression is literally an expression. Because in .NET 3.5, it was only intended for these ever to be used in single-line expressions, not entire methods. They don't support the concept of invoking one piece of logic and then invoking a second piece of logic. They only support the concept of an expression, and all expressions have to have values and have to have types. So, when we try to invoke a void method, basically what gets compiled is this. Which, that doesn't make any sense. We're assuming that method is void here. You can't return void. That'll result in a compiler error. So we can't do that. Well, the only solution that I can come up with in .NET 3.5 is to wrap it in a different lambda. So I'm basically compiling a lambda and then I'm wrapping it in another lambda that will give me the extra block that I need in order to invoke this. So what I'm going to do is I'm going to say if method.return type equals type of void. Then I'm going to say var void lambda equals expression.lambda. I'm going to pass in action, object, object array, and leave it at that. I'm going to pass in call expression, target object parameter, and arguments, or sorry, argument array parameter. Oh, wow, why did I do void there? Derp. Var void lambda, and then I'm going to say var compiled void lambda equals void lambda dot compile. Then I'm going to say return target args compiled void lambda, passing in target and args, and then returning null, and then terminating that. Okay, there's a lot of really interesting stuff going on in these few lines of code. First of all, I say if method return type is void, then we have to do something special. Second thing I do is I do an expression.lambda. So the expression.lambda allows me to create effectively what's a method. But what's interesting about the way this works is that you have to pass in a delegate as a generic type parameter that specifies the type of the type of the lambda we want to create. Now, the type of the lambda we want to create, unfortunately, only has the option of being this, since we can't return anything. It has to be an action, or another delegate that returns void, and then we have to pass in these two parameters. We have to pass in these two parameters because that's what we specified right here. The next thing we do is we specify the body of the lambda, which is simply our call expression. The final thing that we do is we give it a list of parameters. Just like how when we write a method, we would give a method a list of parameters, when we build the lambda, we have to tell it about the parameters that it expects. So this is basically what wires these objects up with the way that I reference them in other bits of the method. So you have to make sure that you're passing in both those parameters into the .lambda method. Then I simply did compiled void lambda equals void lambda dot compile. This is where the magic happens. By doing dot compile, you are now creating actual IL code that is injected into the app domain and will be as fast as any other C# that you may have written at compile time. The final thing that I do is think of this like an adapter. I adapt the concept of a void lambda into a lambda that returns an IRPC response, but of course I have to return something, so in this case I return null. So this allows me to get away with doing the thing that I can't do in .NET 3.5. Now if this were .NET 4, it would be a lot easier, but unfortunately it's not. Anyway, so that's an early out in the case of void methods. Now let's look at normal methods. Normal methods are pretty straightforward. I'm say var lambda equals expression dot lambda of type func object array IRPC response. Then I'm going to pass in, just like before, I'm going to pass in our call expression, target object parameter, and argument array parameter. Then I'm simply going to return lambda dot compile. All right, so that's basically our compile method invoker method. Say that 10 times fast. I'm going to go ahead and delete this example method right here. So now let's see if our test passed. We still get a failure, so let's go ahead and look at that. We get a null reference exception right here. Okay, so I bet you we're getting a null reference exception because I misspelled something. That's commonly what happens to me. When you invoke the get method on a type, if the method can't be found, it conveniently returns null instead of throwing exception for whatever reason. I don't know why, but whatever. Okay, it's void method no params. Okay, so that's why we're getting the null reference exception. It couldn't find that method because I had a typo there. All right, let's go ahead and run this again. And success. I'm going to go ahead and copy and paste this test. And I'm going to say can invoke void method multiple times on component. And then at the top of this test, I'm going to write const int target invoke count equals 0. Or sorry, how about equals 30? And then here, I'm going to say for var I equals 0, I smaller than target invoke count I++. I'm going to invoke it multiple times. And then I'm going to say call count should be target invoke count. Let's run that test again. And we get success. So before I end this video, I want to go ahead and show you guys what these, or let's go ahead and test the params ones first, I guess. That should be easy enough to do. I can do that real fast. Public void can invoke void method one param on component. Var map equals create test component 3 map. Var component object equals new test component 3. And then I'm going to say map.methods 0 1 dot invoke component object. Then I'm going to pass in a new object array that's going to contain, let me remind myself what type that is. It's going to contain a string. And the string is going to be hello world. In fact, I'm going to go ahead and constify this. Const string param1 equals hello world. It's when you're doing tests, it's better to do that. Let's just go ahead and do new object. Don't do the implicit typing there, just to prevent the obnoxious case of .NET allowing different arrays to be compatible with each other, even though it leads to errors down the road. Now I'm going to say component object dot void method one param call count should be 1. Component object dot void method param1 should be param1. So this is ensuring that we are actually invoking our parameters. And that works. Let's go ahead and do one more test. I'm going to copy and paste this. I'm going to say can invoke void method 2 params on component. Param1 is going to be a something, because I totally forgot what param1 was. It's a Boolean. So I'll do bool param1 equals true, and then I'll do const int param2 equals some arbitrary integer. Then I'm going to say methods 0 2 dot invoke, passing in param1 param2. Then I'm going to say void method 2 params call count should be 1, and then void method 2 params param1 should be param1, and param2 should be param2. Go ahead and run this. We get success. I am kind of worried about this working all the time. Let's just change the number right there and see if this fails. It should fail. Yep. Alright, sweet. So it is working. That's cool. We could also verify this working by jumping all the way up to our test component 3 and setting a breakpoint right there, and then hitting this fancy little debug button up here on our unit test sessions. Well, it's not going to do that one because we did void method 2 params. So let's hit debug. Look at that. We hit this method. We hit this method without statically referencing it at all. And that's basically the cornerstone of exactly what the component map does and what it gives us. So you'll see right here that we have this external code, and then we have this. So it goes into our first lambda, then it goes into this external code bit, then it comes up here. If I go ahead and right-click here and say show external code, you see that the call stack is very, very, very small. So it goes all the way from here, doing the invoke method on it, on this component object, passing in these 2 parameters. It goes into this small little wrapper lambda that I had to write because we're in .NET 3.5, not .NET 4. It goes into a lightweight function that is compiled at runtime, and then it goes straight into that method. So no nasty method info.invoke, and this should give us perfectly adequate performance for doing this. So it's just really it is really satisfying seeing that work. Just being able to use these 2 numbers to, in a weakly typed way, invoke a method, but not have it suffer the typical performance problems that you would normally encounter. Alrighty, you might have a couple questions like, for example, what happens if I pass in not enough parameters? Well, you get an index out of bounds exception. What would happen if I passed in incompatible types? Well, you would get a um, invalid cast exception. What happens if you pass in a null component? You get a null reference exception. Basically, you just get the standard set of exceptions that you would get otherwise. And that's fine. Because again, a lot of this code, I don't want to have handling exceptions in any way because I want those exceptions to bubble up. If these exceptions do happen, that is an indication of a bug and needs to be addressed immediately. And it's not something that I want to cover up in any way. So I'm aware that this code isn't going to, or can throw these errors if you misuse it, but I'm content in that it'll throw errors if you misuse it, because then you know you're misusing it. All right, the last thing I want to do is jump over here to the mapped methods, and I want to take a look at something really cool about the expression library and show you guys this real fast. I'm going to set a breakpoint right here, and I'm going to go ahead and jump into debug. So what's really cool is going to be actually inspecting these expressions. So let's look at this call expression. If I open this up, there's this thing called debug view. And this debug view allows me to see a kind of sort of close to C# representation of what the dynamic object or what the dynamic code is going to look like. So as you see in this case, all we have is a cast. So we cast target object to our component 3, and then we call void method no params on it. So what about the lambda? If I open up the lambda's debug view, it's a little bit more interesting. We see what looks like a method signature up here with 2 parameters, and then we see the expression body right there. Let's look at a more interesting method. If I come up here to the void lambda for our 2params method, you'll see exactly what it is that we are dynamically compiling. Basically, we have this method right here. It has 2 parameters, a target object, and then what's cool about it is you can see right here us casting the indexing operations of our argument array into the correct types. And that's basically it. All right, so I hope you guys enjoyed the video. If you want to know more about expressions and stuff like that, I can dive into it further if you guys are interested. But for now, I think we'll go ahead and move on. So we'll see you guys in the next video.